Hey everybody, today we have a problem that may look challenging, but it really isn't so bad if you remember the notion of order in number theory. We're trying to show that x equals 9 elevated to the power of 14 factorial. Yes, that's 14 factorial, not 14, is a solution. That means when we substitute x in here, do all the calculations, it will be a multiple of 14 is what this means. Okay, it leaves a remainder of 0 upon division. Okay, by 14. Now, the approach here is fairly straightforward if you just remember, first of all, it's important to remember what this object is. 14 factorial just means 2 times 3 times 4 times 5 all the way up to 14. Okay, and I'll leave out the stuff in the middle. Okay, so that's the meaning, and of course I intentionally left out 1 since it's not necessary. It's the multiplicative identity. Now, a fact that turns out to be super helpful here, and first of all, this is theoretically has to be a solution, but because the order of 9 modulo 14 would have to be a number in this list, so theoretically you could say done basically, but we'll be more concrete about it. Again, and this requires some computation here. A fact that makes this problem fairly straightforward is that 9 cubed is congruent to 1 mod 14. And that means when you compute 9 cubed and subtract 1 divided by 14, you get a remainder of 0. But a way to do this from a modular arithmetic perspective, I'll go ahead and show you why it's true. This is the same, 9 cubed is the same as 9 squared times 9, right? Okay, but this is congruent, and I won't do all the calculations here, but 9 squared is 81, and so 81 leaves a remainder of 14, a remainder of 11 when you divide it by 14, so you would get 11 times 9 here. Okay, it's congruent to that, but this is equal to 99, which is congruent to 1. Okay. So that's the calculation here. Again, when you divide 14 into 19, 7 times 14 is 98, so you have a remainder of 1, right? So this is just a quick modular arithmetic proof of this fact. But you see, once we have this, see, it's pretty clear that we're essentially done with the problem, because notice what we would have right here is, well, 9 cubed, 14 factorial, let's just write it. 14 factorial could be written, okay, as, well, let's just, probably a better way to put it is just like this, just the same thing I wrote down up here, but you could write 2 times 4 times 5, 14 right here, and then it's all multiplied by 3, right? See, I just wrote it that way for convenience because we can call this part right here just m. We don't have to name this number. We'll just call it m, okay? And so what we get right here is that x, or this value right here, x is equal to 9 to the 14th, 9 raised to the 14 factorial. You can see that that would just be the same thing as, let me just write it over here, x is equal to 9 cubed, and this is just laws of exponents right here, raised to the nth power, you see. Now, if I was real precise about it, I would go ahead and write down all of this, 2 times 4 times 5 times 14, but that's a little cumbersome. You see, laws of exponents in this truth right here leads to this, another way of writing this solution, right? You see, notice this is clearly congruent to 1 raised to the m power, and no matter how big m is, 1 raised to any power is just 1, right? Okay, and so what we get right here is a very easy solution to this. In other words, this would just be the same as 6 times 1 mod 14. This would be 5 times 1. Again, everything inside is mod 14. 4 times 1, 3 times 1, 2 times 1. And of course 8 is just 8 mod 14, but this would be plus 8. Now what is this, folks? This adds up to 11, 15, 18, 20, 28. But 28 is a multiple of 14. So this is equal to 28, but obviously 28 is a multiple of 14. It's 2 times 14. So 28 is congruent to 0. And of course we are talking mod 14 here. So that does it. That's the proof of this. And it's kind of nice. You could have thought of, you could always think, you could think of phi of any integer, you know, phi of an integer is going to divide 14 factorial. For this particular integer n, I mean for 14, its order is guaranteed to be a factor of 14 factorial. And so you could just say done without doing a computation at the beginning if you wanted to say theoretically this is true, because phi of 9 divides 14, since 9 and 14 are relatively prime. But this is just a more concrete way of doing it, just showing you what's going on here with this computation right here, and then writing 14 factorial this way, and then rewriting x like this is 9 cubed, which is known to be congruent to 1. And then that just essentially we're done with the problem. So this huge 9 to the 14th is hard to say. 9 to the 14th factorial, that would fill up 2 screens of digits, if not more. Okay, it's an unpronounceable number, unimaginably long, but we have shown it as a solution to this 5th degree polynomial. All right. Thanks for viewing.